So good morning, everyone. During the physical event, I have shared an example about a project that was designed, and I'm going to briefly uh, repeat that example. Basically, it was a project that was designed with an air-cooled system, and I got involved early enough in the project. The project capacity was 3,500 ton, a residential building, a horizontal building, right? And during the discussion with the designer, I was investigating why he went with the air-cooled system, and the answer is that it's a simpler system, it's a cost-effective system, of course, initial cost, and it's a less complicated system. Now, we went through a discussion about the initial cost, and one of the things that we went through is that the initial cost is not only related to the HVAC equipment, but on the other hand, it has many parameters involved. For example, the transformers that were required to power up those chillers, right? Because 3,500 ton will require almost 8 air-cooled chillers, right? And when we looked at that cost, it was massive. We looked at the surrounding of the buildings and the design of that buildings, and we noticed that this building is in the middle of a residential area surrounded by other residential buildings. And from one direction, it had a residential building which was 5 stories higher with balconies overseeing that roof. We're seeing all the 8 air-cooled chillers. So I requested him to allow me to do a study and analysis over the operational cost of that system. And that's what happened. We did an 365 days analysis, 8,760 hours of analysis of power consumption of a water-cooled chiller with cooling towers compared to the air-cooled chillers, right? The results were stunning. And the consultant, after seeing that results, right, he started asking further question, the noise criteria, the noise level, the location, and how can changing the system from an air-cooled to water-cooled will give him more space in the roof, for an example, to have more common area, right? And after almost 2 to 3 weeks of analysis and submitting data, performance, the consultant was convinced that the water-cooled system for that specific project was a better solution. Of course, this is not a rule of thumb. However, for a larger capacity and that specific location, the advantages of the water-cooled exceeded the air-cooled system. And my today presentation, my first part of the today webinar is the advantages of the evaporative cooling, right? So the design goals. For any system, when we design, we are looking at specific outcome. We need the comfort of the tenants, the efficiency of the system, and of course, the cost, and not referring to the initial cost, but the running cost, right? Those machines which you are installing will run for 15, 20 years, sometimes even more with the proper maintenance, reliability of the system, and the sustainability. Technically, we are looking at all these aspects, right? So what are the advantages of the water-cooled system? First of all, the evaluated cost, operational cost, the running cost on the long term, energy efficiency. But this is one of the most important advantages of the water-cooled, which will be covered later on throughout our presentation. The comfort and the capacity given by the water-cooled chillers, right? The limitation on the capacity and the air-cooled compared to the water-cooled is massive, and I'm going to cover it in the next few slides. The noise and the maintenance times. What I refer to is the number of fans, correct? Usually the cooling towers and the air-cooled will be installed on the roof of any building. If you compare the number of fans by the cooling tower, you require 2, 3, or 4 cooling towers versus on a large capacity project, you require maybe 6, 7, 8 air-cooled chillers. The number of fans will generate a lot of noise, which is a very important factor. The footprint, right? Again, related to the capacity. In the same capacity, you can have a smaller number of equipment. And the total water usage. Total water usage is, I'm referring to the power generation, the power plants, our power plants which feeding us with the electricity, consuming more power will require more water at that specific plant. So we are not looking at a building level, we are looking at a district level, right? Now, a small comparison between the air-cooled capacity and the water-cooled capacity. The air-cooled is limited almost to 450 to 500 ton maximum, and it cannot go beyond that, while the water-cooled chiller can even go to 3,000, and in the recent last couple of years, I have seen even chillers went to 3,500 ton and even more with the double compressors type of chillers, right? The second most important thing is that the air-cooled chiller is relying on the dry bulb, right? And we all know how high is our dry bulb in this region, while the evaporative cooling system is depending on the wet bulb. When the difference between these two can, and the peak summer can be even more than 10, 12 degrees, which again, we will go into details in it in the future slides, which will be covered by my industry colleagues. Right. The value of the evaporative heat rejection versus alternative system, you will inquire almost 50% less in terms of energy usage. Of course, this is applicable for a specific, or I'll say a minimum capacity. I'm not referring to a 700-800 ton project. I'm referring to large projects. You will inquire a big differences when it comes to the energy consumption. Right. Gas emission, air-cooled versus water-cooled. Gas emission is something very important, and everyone is referring to, and the government organizations are always following up to reduce the gas emissions. Right? Water usage, 40% almost less water consumption. Again, that's referred to the power plant, the power production facilities. And some of the other benefits, which are the noise, which I just covered, 2 fans, 3 fans in the cooling towers versus large number of fans on the air-cooled chillers. The environment, right? Cooling towers is made of mainly the PVC fills and very less metal, right? Which is good for the environment. And finally, the space, right? And I gave that example, the roof of the building, and instead of 8 air-cooled chillers, we end up having only 3 cooling towers. 3 fans versus around 20, 25 fans, right? In terms of space, the dimension of those cooling towers were almost 5 times less than the capacity that will be occupied by the 8 air-cooled chillers. Right. And finally, the benefits, again, the 50% reduction on the consumption, decreasing the load on the power grids and the power stations, which we all see how DEWA and the other authorities in the different countries are always incentivized and promoting the reduction of the power consumptions, right? For example, I'm receiving a monthly newsletter from DEWA showing me my consumption compared to others, compared to a similar apartments with the space, and I get my monthly ratings, good, equal, more, less. This is something very important. And finally, again, I'm going to refer to the power consumption. Yes, on the site level, on the building level, the water cooled will consume water. But if you're going to compare it, the water required to overcome the energy consumption generated by the air cooled, you'll find it almost, it's like 30 or 40% less than what you're going to consume at your building. This is an example of a 400-ton air-cooled versus water-cooled. At the power grid, it requires 2.1 million gallons versus 1.3 million gallons over per year, right? And these data have been backed up by studies, and this article was sourced from the alliances of Legionnaire, all right? And this will be the end of my first presentation.